Welcome back, students. We just completed a graph problem here, this one. And what can I say? It was hard. Here's a brief review of what we did. Plotting the graph, okay. We did Desmos graphing calculator, and also we had mathematical presentation here. Looks like this, okay, alright. And then we want all intercepts and asymptotes, so okay, y-intercept here, x-intercept here, and vertical asymptote here. Y-intercept is easiest. Plug in x equal to 0, no problem there. X-intercept, numerator is equal to 0, so that was an exponential equation. See, the numerator has to be equal to 0. And then you can solve it by solving for exponential and then taking the logarithm. Now the vertical asymptote, we take the denominator equal to 0, and we have a log equation. Alright, so for the logarithm and take the exponential, that will remove the log, and then we get the x value that corresponds to this vertical asymptote. So we wanted those three, and we found out those three, and that's the end of the problem. Some additional comment here. They all match the graph, but there's one more potential problem, that is log of 0. Log of 0 can become a problem. No, not here. Log of 0 here, going down to negative infinity like this. But in this particular case, no problem there, because log of 0 in denominator, so this entire thing goes to infinity, or maybe negative infinity, but who cares? Denominator is infinity and numerator is something, so the overall quantity is going to go to 0, and that's what you're looking at over here. So no more vertical asymptote, and this is not really a 0 either. Anyway, that completes the review on this problem. And we have another problem like that here, a little bit harder. Ready? Okay, plot a function, and let me get this Desmos graph calculator ready. Let me stop the plot. Okay, I prepared the graphing calculator here. Okay, after stopping the recording, I prepared this, and then I have this graph here. Please check this and that. So this is a graph. Apparently we have a vertical asymptote here, and we have an x-intercept forming here, and then y-intercept over there. And do we have another x-intercept here, or is just horizontal asymptote? It's a little bit hard to tell. And looks like it is stopping here. Weird graph. So let me expand. Y-intercept, x-intercept, and vertical asymptote. Okay, all right. Similar kind of graph here. Okay, with a little bit different scaling, but it's the same graph. Y-intercept, x-intercept, and then a vertical asymptote. Okay, easiest of the bunch is of course the y-intercept for plugging in x equal to 0, and that's about it. So here we go, plug in x equal to 0, and then run your simplification. That's a simple expression here, and then run your computations. You get 0.026 something, and yes, 0.1, so this is 0.26 something. Yes, okay, it makes sense. Okay, so much for y-intercept. That's too simple. Now x-intercept. function value is equal to 0. So what do you have to set equal to 0, and so for what? You have to set the numerator equal to 0. So 5 minus 3 log of 4 minus x is equal to 0. Solving this equation. Good luck. Everybody tried? So for a logarithm and then taking exponential. Okay, here we go. Oops. I go for a bit too much already. So numerator equal to 0, and then solve for natural logarithm. So flip 5 to the other side and then flip by this 3. So we get that. Okay, so we have 5/3. Alright. And then take the exponential of both. So that will remove this logarithm. So taking the exponential of both. So inside 4 minus x is equal to e to the 5/3 power. It's easy. Flip 4 to the other side and some further computation. You're going to get x is negative 1.29 something. But this is not really necessary. This expression here is perfect answer. Negative 1.29 something. Let me see. Yes, okay, this is negative 1 here. Negative 1.5 is here. I'll be less than that. Okay, it fits. It makes sense. Now the vertical asymptotes. This time we have denominator equal to 0, alright? So we expect something over here. So this is gonna be 2 exponential of 2x plus 3 minus 8 is equal to 0. So we have this exponential equation. Good luck. Well, did everybody get the answer or close to it? Well, here we go. Flip 8 to the other side and divide by 2, so we get exponential is equal to 4. And then we can remove the exponential by taking the inverse function. Take the log of both sides, and here we go. 2x plus 3 is equal to log of 4. Solving for x, not bad. Flip 3 to the other side, and then flip this 2 to the other side. We get negative 0.80 something. Let's see. Yes, it fits. So there goes the vertical asymptote. Does it fit your graph? Yeah. Or 3 matched. Vertical asymptote we just found out. X-intercept, y-intercept, all those. In fact, there's one more potential trouble. When x value gets pretty close to 4, you may end up with log of 0 situation again, you see? Log of 0. No, different cell. Log of 0, yes, going down to negative infinity. And this time negative infinity shows up in the numerator. So previously it was in denominator, so something over infinity, so that's 0, no problem, but this is problem. So we have negative infinity here, log of 0. So if you plug negative infinity there, negative is positive, so we have positive infinity. The graph must blow up to positive infinity as x gets pretty close to 4, so we should have another vertical asymptote as we move to x equals to 4. But the problem is, now this is just a limited expression. You see, in smaller scale you see something, but otherwise you don't really see it. It's very difficult to see. Look at these scales here. Not convinced? Okay, let's go back to this Desmos graphic calculator. Go pretty close to 4. Do you see any asymptotic behavior here? Vertical asymptote forming. We have sudden up spike here, but that's about it. Oh, a little bit more. Maybe a bit more as I zoom in, but no more. That's because it went beyond this machine resolution of these computation. And this kind of thing happens. Even if you use technology, even in today's technology, you can't see everything. Eyes can be deceiving. Interesting, isn't it? But then again, of course, this kind of deceiving problem is really ultra high level problem for this course. So even if you missed it, it's gonna be okay, but still one more thing to check. Okay, all right. We went through graph problems. The standard y-intercept, x-intercept, vertical asymptotes given by the denominator. Those kind of things are standard. You should know how to do those. And each of those will be, well, y-intercept is direct plating, but the others are exponential or logarithmic equations typically. So graph problems can be quite comprehensive. Speaking of comprehensive, here are even worse. Domain problem, in that case, typically we have to do inequalities as well as equations. Ready for one? Maybe I'm not going to spend too much time on these. I'll just move on really quickly. Let's see, we have logarithm here in the numerator, and then we have denominator there. So denominator should be non-zero, so set up equal to 0, then you're going to get some vertical asymptotes given by the denominator. The numerator, the inside of the logarithm has to be strictly positive, so we have quadratic inequalities, so you're going to get some interval. And basically we have this kind of graph here. Let's see. When x is positive infinity or negative infinity, throughout those, it's okay, but inside the logarithm may become negative, so things will become a bit troublesome there. And here are symbolic solutions. Inside of the logarithm has to be strictly positive, so you can solve this quadratic inequality. So we have -1 to negative infinity to the left, -1/3 to positive infinity to the right. And then setting up the denominator not equal to 0, we'll have to remove more points. So from here, I have to remove -3. From here, I have to remove +1. So we have these two intervals here, those two intervals there, and between -3 and between -1 and -3, excuse me, we don't have anything there. So between those two, nothing. And then we have vertical asymptote here, there, and horizontal asymptote forming those. That's where I'm going to stop. The next problem, we have square root, and then we have denominator. So the square root gives you a certain region, so only from here to there is valid, I guess. No, it's coming from logarithm. Logarithm is strictly positive, so -2 to +2 only there. So only there. And then this one has to be non-negative, so some outside somewhere. And then some vertical asymptote forming from the denominator. I don't know. The detail is left to the students, and only self-selected students only. These are way tougher than the kind of problems that we went through in lesson 11. Okay, that completes this lesson, and we're going to talk about exponential and logarithmic equations in Module 13.